All right, so let's ls into it. We are going to find our files here. And let me also say that I have other tutorials on SPADes for genome assembly. So there's one where I showed how to use the Galaxy platform. There's one where I showed how to run SPADes directly on the command line. So if you're interested in those ones too, you can check the discussion box for those videos. So you have a bit of both words. Let me just put it that way. All right. So now you can continue. So let's clear the screen and then continue. All right, so let's do an ls again. Let's do an ls into our FASTQ directory to check our file. So we are now going to perform the genome assembly. So we are going to write our Nextflow scripts to perform genome assembly, and this is going to be our input. We have paired and reads. So let's continue. Now we already have Nextflow installed, and so you should also make sure that you have SPADes installed. Again, instructions for installing Nextflow and SPADes can be found in the description box. So use them to set up your PC. And you should also download the example data. All right. Now let's proceed. So let's do this. We need to take note of some things here. First of all, we need to take note of the path for the files. I have a paired end data. So this is read 1, this is read 2. I need to get a path for both. All right. So I'll just get a path. So to get a path in Linux, you can use the rel paths utility. So I'll say rel path, and then I'll say fastq / and I specify read 1, for example. So that'll give me the path. And then for read 2, it's still the same approach, but this time the file name changes to 2. So I have them here. Alternatively, you can just use a pwd to get the current directory, and then you add /fastq, and then you add your / file name here. So that's it. So that's what we need. And we also need to take note of the sample name. We will use it later on. So just take note of that. All right. So for me, I will just take note of this one. I will do everything else in the script. So that's it. Now let's proceed. Now let's open our Nextflow scripts. We are going to continue with this one. So that means that means that we are going to add on to what we have already done here. So I'll open it. So I'll say nano pipeline.nf, and then I'll open it. All right, so I have that done. Now I'll do this. When I come here, where I initially specify the parameters, I'll add the read 1, read 2, and I'll add something else. Let's start with the read 1. So I'll say params.read1 equals, and then I'll say /home/ so there's a 4 path /_ 1.fastq.gz. This is for read 1. params.read2. It's still the same thing here. I'll just do a copy and paste because it's long. I'll just do a copy and paste here. _2.fastq.gz. All right. Now let's also do this. We are going to add another parameter. So I'll put that also here. So this parameter, I'll say params.SPADes out, or let's say output. So this directory is where we will place the SPADes output files. So I'll define it here. So again, it's also /home/ / this /SPADes output. All right, so this directory we will use it. So we are also going to use this one. We will use it as we did here, the publish the function here. So don't worry, we are taking it step by step, so you'll get there. So these are the only things I need for now. So now I'm going to add another process for the assembly. So I will scroll down. And then when I scroll down, I'm supposed to scroll down to this side. Let me just go over again. So from here, all right, from the last line of the params. I scroll down to the side. It should come before the workflow. That's how I prefer to do mine. So I'll just do it here. I prefer to bring it before the workflow, this one here. So this is the next process. So I'll define the status. So I'll say process assemble. You can also use assembly, whatever, it's up to you. And then I bring my curly brackets starting and then ending. And then in it, I'll use my publish dar. So I'll say publish dar, and then my brackets, double quotes, dollar sign, curly brackets, and I say params.spades outputs. All right, let's just confirm the name. Yeah, so spades outputs like this, and then I bring my curly brackets, I close it, and then I bring my comma, and then the mode. That will be mode colon, and then it becomes copy like this, and then we bring our brackets. All right, so this is how we do it. Okay, so that means this directory will be created, and then the spades outputs will be saved in that directory. Now let's proceed. Let's scroll down. Now we have to define the inputs for this process. All right, let me just do it here. Just make sure you have your curly brackets, yeah. Now we have to define the input. So the inputs here, we will supply two files, read one, read two. So input colon and then space, I'll say path. All right, and I'll say read one, and another one again, path read two. These are the inputs, and then the output colon, and then when I come, I'll say path double quote star double quotes. This is it. All right, so this is it. Now I bring my comma and I'll say emit, and then I'll say outputs. You can put it like this, that's fine. Or you can also be specific or the script. So you can say spirits outputs. That is up to you. So that one, you have to decide the name that you want. All right. So we'll do it this way. Now we have to enter the command. So this is where it gets interesting. Let's just go down a bit. So that's a script. You bring your colon, three double quotes, and then inside we will specify our spades command. Okay, now with spades, if you are going to use it, you also need to specify an output directory. Now let's take a look at something. We will come back to this script. Let's do an ls into our fastq directory again. We have our fast. Now with the output, what we want is to supply the sample name minus the .fastq.jz and this _1 here. So _1 _2 are used to differentiate between the forward and reverse. But we want space to create a directory called this, and then everything here is omitted. So we just want to have a single directory with the output. So I'll show you an approach to deal with it. Sometimes it gets confusing for beginners, but I'll show you everything now. Okay, so I'll still take note of these ones, this sample name here. We don't need to paste it. I'll show you everything. So in this script, all right. So ideally for spades, this is how we should run it. Let me just show you the command we are supposed to use. So it's going to be spades.py. And then this is how I'll use it. That's careful. And then I bring my -1. That's for read one. Let me just bring this one here. Read one. -2 $read two. And then -o. All right, it's going to be this one here. Okay, let me just do it. I think this will be better. Say -1. -2, and then I bring my sample, and then -O will be this name here. This is the command that we are supposed to use. All right. Now, if I run this, on my terminal now, it's going to work. Okay, let's try it. Okay, it's working. That's fine. Let me just cancel it. We don't need it now. And so if that command has been successful, you have all your files, but still, let's do an ls. We are going to find this directory being created. All right, here. Okay, so the command line version worked, but in Nextflow, the command will change slightly. Okay, so this is where you need to pay attention. The command will change slightly for us because we are using Nextflow. All right, so basically, this is what we are going to do. This is what we are going to do. So I'll show you how to write it in Nextflow. So first, let's remove the directory that we created, this one here. We don't need it now, so I'll remove it now. Okay, it's gone. So at the end of the day, what we are going to do is to have a bigger directory, or let me just say one directory, and in it we will have this file, no, this directory also in it, a subdirectory which has the SPADes output for this sample, right? So that's what we are going to do next. So I thought I'll show you this first before we start now. Okay, so now we are here. So if you are here, you can type your SPADes. All right, spades.py -- careful, and you say -1, and -1 will indicate our read1. That is $read1, and then -2 is for $read2. All right, and -O is supposed to be the sample name, the output. But at the moment, there's no way. With what we've done, it becomes difficult to get the sample name. All right, now under normal circumstance, if you want the sample name, let's just do an ls again to this directory. If you want a sample name, you can process any of them using some text processing utility. You can just do this. Let me show you. I do it a lot. You can just say base name Pascal, and then you specify, let's say, one of them like this, and you can say _1.fascio.gz. all right, so if you run it, you get a sample name. But in Nextflow, you have to do something different, okay, to still get it. So I'll show you that also now. So when we come here, we are going to clean everything. So here, the approach we are going to use is a combination of X-Ax and then the SPADes command and then some other stuffs. That's what we are going to do. So here, what we are going to do is to first get the sample name. That's what we get first. We want to get first, and then we will pass it to the SPADes command. All right, so to get a sample name, this is the approach I'll use. I'll use the echo command, and then I will do this. I will also bring the read1. That's what I want to use to process. It doesn't matter anyway. If you use read1 or read2, the same principle. So I'll say $. I bring my curly brackets and I'll say read1. And I'll say .simple name. All right. So if I use .simple name, that's what happens. You'll get this up to this one here. But then we also want to remove the _1 as well. So that's what we are going to do. We are going to use the cat command. All right. You can also use the awk. That's also fine. So that's what I'll do. I'll bring this pipe and I'll say cat, and I'll say -d. That's the delimiter. I bring a quotes, underscore, and this. So the delimiter here means that the text will be cut. wherever there's underscore, it will be cut. So you have a split. So when we split, in this situation, when we split this and this, we are going to have two values, this and then this. But we want the first one. And therefore, when we come here, we will say -F1. We want the first one. All right. And then after cutting it, then we can bring x-axis again. So x-axis will help us to push the outputs to SPADes. And then I'll say -I. And then I'll say SPADes.py -- careful. And then I bring -1 $read1 -2 $read2. And then I'll bring something else. I'll say -O like this. And then I bring a quote. I bring two curly brackets, one opening, one closing. So this curly bracket is going to be a placeholder for the output of this. The output of this, which is this one here. That is the s-axis command. Okay. That's how it's going to be. And once we do that, means that everything is complete. All right. So that's why I made mention that when using Nextflow, some things will change slightly. So this is now the final SPADes command. All right. So we are good to go. Let's just streamline the stuff as well. Okay. Now the x-axis, if you are dealing with multiple samples, then there might have to be some variation in how you use it. But for now, we are dealing with a single sample. So that's why I'm using this approach. All right. But there are other approaches you can also use if you have multiple samples. All right. So most of these commands, it will depend on a number of factors, which include the number of samples and etc. But for now, this one will do fine for us because we have just a single sample. So that's it. So this is it for the process assemble. Okay. That's the task. And then we can continue. We need to also make sure we have our curly brackets there. That's it. All right. So this is the final command for the assembly. All right. So that's it. Now we need to create a channel that will supply this process with the read1 and then read2. All right. The publish that will also make sure that we have access to the outputs when everything is done. So let's continue. So now we will come to the workflow. Let me just do this. And then we will continue. Now with the workflow, we still have the command for the downloading of the files, but we don't want to run it again. So you can make it a comment. So in Nextflow, we have single line comments and multi-line. So this time I'm going to comment out all these ones. I don't need them for now. I'm going to comment them. So this will be the command to comment them out. All right. And then I'll rather come down and prepare new ones. All right. Alternatively, you can decide to just remove them completely, but that one is up to you. So you decide, but commenting them is also fine. Now I'm going to run the assemble command by first creating channels to supply that process with the input files. So I'll say read1 underscore ch because channel.from path, and I'll say params.read1. And then read2, let me just add a space here, read2 underscore ch underscore like the ch equals channel dot from path, and that will be params dot read2. All right. And then when we come down, we can call the assembly process. So I name mine as assemble like this. And then I'll bring my brackets and I'll say read1 underscore ch comma read2 underscore ch like this. And then when I come down here, I'll just say assemble dot out dot SPADes output.view. All right, let's just confirm this name here. You know, we had this emit, so this one here. All right, that's it. Okay, some people may choose to use other ways to display the content, but I prefer to use this one here. So that's it. So once I'm done with this, I need to make sure that everything is correct. I have my curly brackets and everything, and that's fine. So this becomes our final command to perform the genome assembly. Let's just go over again to make sure that the names, everything is correct. So it's fine. Inputs, outputs, yeah, everything is great. Okay, so now we can proceed. So let's exit and save changes. All right, I'll just do an ls again just because I like doing it, and then I'll run the command. So I'll say nextflow run pipeline.nf. All right, so now let's execute this command. Okay, so now Nextflow is running. So this particular activity, when I started it took about 15 minutes for everything to get done for me. So I expect it to be the same for you, or maybe it will be faster depending on the computing power that you have. So let's wait for Nextflow to complete this task. Okay, so the genome assembly process has been completed. So you will see this log here just to let you know what has happened. All right, now let's take a look at the output file. So now if you do an ls, you are going to find this directory SPADes underscore outputs, and if you ls into it, you are going to find this directory which has the output files for that sample. So let's ls also into it so that we see those stuffs there. All right, so we have the files here. All right, so these are the outputs for SPADes. Now after performing the genome assembly, it's also important to evaluate the genome assemblies. So you can use tools like Quast. You can also use tools like Busco. I've covered some tutorials on them, by the way. I'll leave the links to those tutorials in the description box. You can also visualize assemblies by using the graph assembly graphs. I've covered a tutorial on that. You can also perform polishing. You can also filter the contigs and remove those that are short. You can also perform genome annotation. So I have an entire playlist on post genome assembly, and so check the description box. You will find the link to those videos, and you can also check the playlist here and you can learn more.